Welcome back, everybody. Today we're going deep on some really fascinating bioelectronics research.
Oh, yeah.
You know,
This is going to be a fun one.
you sent over some research about this new hydrogel semiconductor,
Right.
and it seems like it could revolutionize how we think about interacting with the human body.
Yes, it could.
You know, medical implants that actually feel like they're part of you
Exactly.
instead of some foreign object.
Yeah, and not only that, but even more effective
Right.
because of this material.
So we're talking about hydrogels here.
Yeah.
And I think a lot of people listening have a pretty good idea of what a hydrogel is.
Right.
Like those little water beads you find in,
Exactly.
plant pots or whatever.
Right.
But then, a semiconductor,
One
something
day.
totally different.
Totally different.
Like usually it's hard.
Hard and brittle.
Yeah, you think about like computer chips and stuff.
Mm-hmm.
So how on earth did they manage to combine those two things?
Well, and that's what makes this research so groundbreaking.
Yeah.
Because the traditional ways that we make hydrogels just don't work with semiconductors.
Okay.
You see, semiconductors typically don't dissolve in water.
Right.
And you kind of need water to make a hydrogel.
So it's like oil and water.
Exactly.
You're trying to mix
They don't mix.
two things that are fundamentally incompatible.
Yeah, you can't just force them together.
Okay, so
You got to be a little more clever.
so what did they do?
Well, the researchers
Hmm.
over at the University of Chicago,
Okay.
they had a pretty clever solution.
Okay.
They did something called a solvent exchange process.
Okay.
So instead of trying to force that semiconductor into water, they used a special type of organic solvent
Okay.
that actually mixes with both water and the semiconductor.
Huh.
So they create the gel in this solvent first,
Okay.
and this is the really cool part, they swap out that solvent for water.
Oh, so they kind of tricked the system a little bit.
Yeah, a little bit of trickery.
Wow.
And then you're left with a hydrogel that still has those semiconductor properties.
So they basically found a workaround
That's right, a workaround.
to bridge the gap between those two worlds.
Exactly.
So this isn't just like a mixture of a hydrogel and a semiconductor.
No, it's not like a composite or anything.
Right.
It's a single material
Whoa.
that has both of those properties.
So it's not just like they're sitting next to each other.
Right,
It's like
yeah.
they're one thing.
Yeah, one material.
Okay, that is really fascinating.
It's pretty cool.
I was looking through the paper, and they mentioned that this new hydrogel has something called a
Oh, yeah.
tissue-level modulus.
Right.
I think as soft as 81 kPa
Yeah.
and can stretch up to 150%.
Uh-huh.
No,
Yeah.
I'm not a material scientist.
Right. So what does that actually mean for our listeners out there?
What does that mean?
What does that mean?
So that tissue-level modulus, it's basically just referring to how soft and flexible something is.
Okay.
And this hydrogel, they specifically engineered it to
Yeah.
be as soft and stretchy as human tissue so that if it's implanted in the body, it doesn't cause discomfort or,
Right.
immune reactions.
Exactly. And that 150% stretchability
Yeah.
basically means it can bend and move with the body
Oh, wow.
without breaking or losing its function.
So not only is it compatible with the body in terms of like, its actual composition, but
It moves like the body, too.
it moves like the body.
Yeah. It's got to be able to keep up.
That's really incredible.
It is.
So we've been talking a lot about how this new hydrogel feels,
Mm-hmm.
but does it actually perform like a semiconductor inside the body?
Well, that's what's so remarkable about this research.
Yeah.
It's not just comfortable, it actually enhances functionality.
Okay.
So the hydrogel, it has this porous structure. Right? I
Okay.
can almost think of it like a sponge.
Yeah.
And this porous structure allows for something called enhanced biosensing,
Okay.
meaning it's super sensitive to biological signals.
So it's picking up on what the body is putting out?
Exactly. And its reaction to light is also amplified. So this opens up possibilities for things like light-activated pacemakers or, wound dressings that can be gently heated to speed up healing.
Okay, now that is super interesting.
Yeah, it's really cool.
That's like a game changer.
It is a game changer.
Now, the research paper mainly focused on implantable devices,
Yeah.
like pacemakers and biosensors.
Right.
But it seems like this could have applications beyond medical implants.
Oh, absolutely.
Right.
Yeah, implantable devices are a huge area of interest. But, this material has the potential to go far beyond that.
So what else are we thinking here?
Well, think about advanced wound care,
Okay.
where you could use its biocompatibility and sensitivity to create dressings that promote faster healing.
That's interesting.
Or imagine next-level health monitoring
Okay.
with skin sensors that are barely noticeable but incredibly precise.
So this could be like the future of wearables?
Exactly.
Wow.
So the possibilities really are vast.
It's just amazing how one innovation like this, a change in how a material is made, can unlock so much potential.
It really is.
But before we go too far down the rabbit hole here, let's back up a little bit.
Oh.
We keep mentioning this porous structure.
Right.
What is it about that structure that leads to these improvements in biological function?
So, well, you see that porous structure, it acts like a microscopic network of channels within the hydrogel.
Okay.
And these channels allow biomolecules to flow in and interact directly with the semiconductor,
Interesting.
leading to much more sensitive and accurate readings compared to traditional sensors.
So it's almost like having a sensor with a much larger surface area?
Exactly. It's like increasing the points of contact
Right.
to capture those crucial biological signals.
Okay, that makes sense. But it's not just about sensing, right?
Right.
We also talked about this idea of stronger photomodulation effects.
Yeah.
Can you maybe explain that a little bit more?
Sure.
What does light have to do with this hydrogel?
So photomodulation basically means using light to control biological processes. It's like flipping a switch with a beam of light.
Interesting.
And because this hydrogel is so porous, it's really efficient at transporting light-sensitive molecules,
Okay.
making it possible to use light to trigger specific actions.
So, for example, you could use light to...
Well, you could use light to stimulate tissue growth,
Wow.
or even control electrical signals in an implanted device, like a pacemaker.
So instead of relying on, like, traditional electrical leads,
Right.
you could potentially control a pacemaker with light.
Potentially.
That sounds like science fiction.
Does a little bit.
Now, the research paper did mention that the team has already patented this new hydrogel semiconductor,
They have.
and they're looking at ways to bring it to market,
That's right.
which I guess means they're pretty confident in its potential.
Yeah, they definitely see the value.
But let's think about the challenges for a second.
Okay.
I imagine there are quite a few hurdles to overcome
Of course.
before we start seeing this technology in everyday life.
Yeah. I mean, while the initial research is incredibly promising,
Right.
there's a long road ahead before this becomes widely available.
Like what kind of things?
Well, for starters, scaling up production to meet potential demand will be crucial.
Okay.
Right now, they're creating small batches in a lab.
Yeah.
But to make this commercially viable, they need to figure out how to produce it on a much larger scale.
Right.
And that's not always easy.
Yeah, I imagine there are a lot of kinks to work out.
Definitely. You have to make sure that you can maintain the material's unique properties, even when you're producing it in large quantities.
Right. It's like baking a cake.
Exactly.
Just because you have a great recipe doesn't mean you can automatically open a bakery.
It's a good analogy.
And then, of course, there's the whole issue of testing and regulatory approvals.
Oh, of course.
We need to make sure that this material is safe
Absolutely.
for long-term use in the human body.
That's a big one.
So that means a lot of research, clinical trials,
Mm-hmm.
navigating a complex web of regulations for medical devices.
It's a long process.
But even with all those challenges,
Yeah.
it sounds like the potential benefits here are so compelling
They are.
that it's going to drive continued research and investment.
Definitely, there's a lot of excitement around this.
It's like there's a scientific treasure hunt going on.
I like that.
And this material is the ultimate prize.
It's a good way to put it.
So imagine a future where pacemakers are not only more effective, but seamlessly integrated with the heart.
It's a pretty amazing thought.
Or biosensors constantly monitoring your health without you even noticing.
It's all about that seamless integration.
It's mind-boggling to think about.
It is.
And it's not just about treating existing conditions. It's about potentially preventing them.
Yeah, early detection is key.
With this level of sensitivity, could we one day detect diseases at their earliest stages?
Well, that's the hope.
Wow.
Moving from a reactive approach to healthcare to a proactive one.
Being able to actually prevent disease instead of just treating it.
It's exactly empowering people to take control of their health.
That would be a huge paradigm shift.
It would.
And the potential goes beyond healthcare.
Oh, absolutely.
Think about prosthetics.
Okay.
Imagine prosthetic limbs that provide sensory feedback
Yeah.
and are controlled by your thoughts.
It's like an extension of yourself.
Yeah, blurring the lines between biology and technology.
They're pretty incredible what they're doing.
We're entering a new era
We are.
where our bodies and technology can coexist
Mm-hmm.
and collaborate in ways we never thought possible.
It's an exciting time.
But let's bring it back down to earth for a minute.
Okay.
The research paper did provide some specific examples
They did.
of how this hydrogel could improve existing medical devices and therapies.
Right. So let's dive into some of those.
What were some of the highlights for you?
Well, one that really stood out to me was glucose monitoring for people with diabetes.
Oh, yeah, that's a big one.
Yeah. We were talking earlier about how the hydrogel's porous structure makes it really sensitive to changes in biomolecule concentrations.
Yeah.
So what could that mean for someone, managing their diabetes every day?
Well, I mean, right now, a lot of people with diabetes, they have to rely on finger prick tests
Exactly.
to monitor their blood sugar.
Multiple times a day sometimes.
Yeah. And it's painful.
Yet it's not fun.
And inconvenient.
Not to mention, it only gives you a snapshot.
Right. This is a single point in time.
Right.
But with a hydrogel sensor implanted under the skin,
Mm-hmm.
continuous real-time glucose monitoring could be possible.
Exactly. You wouldn't need those finger pricks anymore.
Wow.
And you would have a much more complete picture of how your blood sugar fluctuates throughout the day.
So no more pricking your finger.
Hopefully not.
That would be a huge improvement for anyone living with diabetes.
Absolutely. A huge quality of life improvement.
And I imagine that constant stream of data will lead to more personalized insulin dosing.
Oh, for sure.
Right.
Imagine your insulin pump automatically adjusting dosages based on real-time feedback.
Wow, that would be incredible.
It would make managing diabetes so much easier.
That's really exciting.
It is.
So what other medical breakthroughs did they highlight?
Well, another area they focused on was pacemakers.
Okay.
Most pacemakers today, they rely on electrical leads that are threaded through veins into the heart.
Right.
But those leads can cause problems sometimes.
Yeah, I can see how having wires running through your veins could be a little bit risky.
It can be.
So it sounds like this hydrogel could offer a much safer and more reliable alternative.
Exactly. The idea is to use the hydrogel to create a leadless pacemaker
Oh, wow.
that sits right inside the heart muscle.
And because the hydrogel is so biocompatible,
Right.
it wouldn't trigger those, inflammatory responses.
Exactly. The risk of rejection is much lower.
So not only would it get rid of the risks from the leads,
Mm-hmm.
but it would integrate much better with the heart itself.
Yeah, it's like it becomes part of the heart.
And they even talked about using light to control the pacemaker.
Oh, yeah, the photomodulation capabilities.
So doctors could adjust the settings without surgery.
Potentially, yeah.
They'd just shine a light on the chest.
That's the idea.
Now, that's what I call minimally invasive.
It is pretty amazing.
But beyond these specific examples,
Yeah.
it's clear that this hydrogel could revolutionize so many medical applications.
Oh, absolutely.
I mean, they mentioned wound healing, targeted drug delivery, even interfaces for the nervous system.
It really is a platform technology.
It's like this single material
Yeah,
has the potential to transform so many different areas of medicine.
it's pretty remarkable.
It really is. It's amazing to think that all this started with a simple question.
What if?
What if we could create a material that combines the best of both worlds,
Yeah.
something that interfaces seamlessly with the human body?
And that question led to this incredible discovery.
And it's a reminder that even when things seem impossible,
Yeah.
human ingenuity and the pursuit of knowledge can lead to groundbreaking discoveries that change the world. This deep dive has been a perfect example of that.
It is.
We've seen how one innovation in material science
Right.
could lead to a future where medical devices aren't just tools, they're extensions of ourselves,
Seamlessly integrated.
working with our body.
Improving our health and our potential.
It's a really exciting time to be alive and to be witnessing this fusion of biology and technology.
It is an exciting time.
And for all of you listening out there, keep exploring, keep questioning, and keep diving deep.